Hi, everybody. Math Tutor TJ here. I want to take a few moments of your time to talk about the Algebra Anchor points. These are the 7 essential skills that students need to be successful in algebra. I've tutored algebra for over 20 years, and every student that comes to me, other than a willful refusal, which is very, very rare, the problem lies in one of these 7 skills. Honestly, um, going through elementary school, the different concepts, sometimes students are allowed to skip over them. And when they get to algebra, algebra is the first introduction into true abstract thought. If the concrete skills are not there when a student moves into abstract thought, everything is lost. Think about it like a helium balloon. So the abstract thought is the helium balloon. So when you get to algebra, you're given a bunch of helium balloons. You need a place to tie them down. The basic skills that you learn going up through algebra, those are the concrete skills. Those are the places where you anchor those helium balloons down so that you can rise. Very important. Skill 1, counting a number value. For most standards in most states, it's called number sense. The reason I've named it number value here is that it rings a little bit more true. It's not so much a number sense as in you get number sense from understanding number value. That's a better way of saying it. And understanding when numbers are more than another number and a lot more than another number. For example, understanding that 10 is more than 5, and more specifically, 10 is twice as much as 5, or that 5 is half of 10. Those are number sense skills. That also helps with checking your work. Understanding that 60 is a lot more than 5, whereas 20 is not as much more than 5 as 60 is. Those are very important number sense skills. I'd like to take a moment here and also remind adults that you've been working with numbers a lot longer than your kids have. When I start at this point, a lot of parents often think, well, of course, that goes without saying. Of course, I don't need to teach that. That's obvious. Understand, in math, nothing is obvious. The kiss of death when teaching math is to assume that something is obvious to your student. Nothing is obvious to anyone until they say it's obvious. So, to ensure that kids are moving along, I don't assume that anything is obvious. I don't assume that they obviously know that 60 is more than 20, or that 60 is 3 times as much as 20. I don't think that's obvious to a student because I understand that students haven't been studying math as long as I have. And keeping that in mind, it's important not to assume that anything is obvious to any student. Okay, so next, the concept of the 4 operations: addition, subtraction, multiplication, and division. At no time in math are we doing anything different than adding something, subtracting something, multiplying something, or dividing something. That's all we're ever doing. The rules may change depending on what we're adding, subtracting, multiplying, and dividing. Each set of numbers has its own rules for that, but we're always adding, subtracting, multiplying, or dividing. Addition is putting things together. That's the concept of it. I'm not talking about any algorithms or recipes at this point. I'm just saying what it means to do it. To add something, you're putting things together. To subtract, you are taking things apart. To multiply, you are adding groups of things together. And to divide, you are separating groups of things. The recipes or the algorithms or the ways of doing things that we learn in school, that we teach students in school, that you may have learned in school, that I've learned in school, those may differ depending on the times. That's usually what the argument is. I learned this recipe and I prefer this recipe over that recipe. Well, it's like recipes for apple pie. Which is better? I don't know. The bottom line is to understand the concept, to truly understand the concept of what it means to divide, or to truly understand the concept of what it means to multiply, the recipe becomes less restrictive. Many times the recipes are changed to enhance understanding of the concept. I know for box multiplication and box division, which gave parents so much trouble a few years back. The idea behind it was to enhance the knowledge, to enhance the understanding of what it meant to divide. Not so much to have a recipe, a rote recipe that you can follow, but to ensure that students understood the concept. Not saying that it was easier in theory than in practice. I'll be honest with that. But the concept, the idea behind it was to promote these concepts. Understanding what it means to do these things is much more important than the algorithm used. Because once you understand what it means to do these things, you'll pick the best algorithm. It doesn't really matter. Okay, so next. Fluency working with those four operations. Now, this is where schools have had to make a choice, and I honestly can't say that I agree wholeheartedly with the choice. Problem solving skills had to be promoted over number crunching. I understand the reasoning behind it. There's only so much time in school, and it is important that students understand concepts and they understand the whys. That's very important. So problem solving skills, I am not saying they are less important, but I cannot say they are more important. It's an and more than an or. Students need number crunching skills and problem solving skills. It's not either or. If the schools cannot provide both due to time restrictions, then it is up to mom, dad, grandma, older brother, and sister to make sure that those number crunching skills are worked on. Numbers crunching skills help with understanding the concepts and with number value. There is nothing that gets anything in your head more than actually working with it, actually crunching it. So, fluency working with the four operations with whole numbers. What are whole numbers? Whole numbers are, well, let's see, make sure my pen is working. Whole numbers are 1, 2, 3, 4, 5, so on and so forth, and 0. Addition, subtraction, multiplication, and division with the whole numbers. Seriously, some method by hand, whether it is the recipe that the school taught or it's a recipe that you're going to teach your kids. In the end, they need a recipe for adding, subtracting, multiplying, and dividing whole numbers. Also need that recipe for adding, subtracting, multiplying, and dividing integers. What are the integers? The integers are the whole numbers 1, 2, 3, 4, and 5, and their negative counterparts negative 1, 2, 3, 4, and 5. This is one of the first places I check when a student is having trouble with algebra, honestly. Sometimes that little negative sign is just completely disregarded. Hey, I saw the number there. That little slash on the side doesn't mean anything. Forget it. As adults, we know that that negative sign means a lot. If for no other reason, your bank account. There is a significant difference between having $50 in your bank account or a negative $50 in your bank account. It's a difference. It is very important that students understand that difference and they are able to add, subtract, multiply, and divide the integers, positive and negative numbers. Next, I should have made this number one, fractions. Do not, I truly do not know how to make this more clear or more important or to emphasize it anymore. Students must have a recipe for adding, subtracting, multiplying, and dividing fractions. Algebra will suck if they don't understand fractions. Seriously, I truly, I've seen it. I have seen an algebra student crumble under the weight of trying to understand an abstract concept that's based on a concrete concept that they never mastered. Fractions will be the kiss of death. Many parents do not know the level of their child's fractional knowledge. Their child got a C or D in math for fourth and fifth grade. Yay, he passed. Yay, the standardized test said that he did okay. Boom, we're keeping it moving. Please check fractions. Please check fractions. Your student should be able to add this, subtract this, multiply this, and divide this. Also, I make a big stink about fractions because it's one of the first areas where the rules really start to change. There are different rules for adding fractions, whether the denominator is the same or different. There is a different rule for multiplying fractions than for dividing fractions. It is the first time many students are face to face or they are confronted with having to memorize different rules for different things. That's why fractions go by the wayside. It's, hey, I got those whole numbers down. These fractions, okay, I need this rule for adding. I need this rule for subtracting. I need to check this before I subtract. I need to do this before I divide. It starts to get confusing. Please take the time to make sure your student understands fractions. I cannot stress it enough, truly. And just in case I didn't stress it before, did I say it before? Fractions are important? Maybe I did say it before. The same goes for decimals. Decimal students don't have nearly as much trouble with because by the time they hit decimals, they have calculators. That's why a lot of students skip over the fractions because they just use a calculator and figure, oh, okay, for 1/3, I have 0.33333. That's good enough. Unfortunately, while that value may work for whatever problem they're working on, not understanding what 1/3 means or how to number crunch fractions hurts them when they're working with rational functions. Last but certainly not least, the language. Um, and what the language means for the operations. When math words are instructing us to perform one of the operations. That's what it's doing. It is important for students going into algebra to have a basic sense of what math words are instructing them to do. For example, sum is instructing them to add, difference is instructing them to subtract. Product is instructing them to multiply. It is very important that students are able to take a math word and understand the operation that goes with that math word or what they're being instructed to do. This is more practice. This comes from practice. This comes from working with word problems. That's why we give word problems so that you can use the knowledge that you have and apply it rather than rote memorization. So again, these are the basics. Of course, if you look in any standards book, it's, this thick and it seems like it's a lot more, but these 7 skills are the essence. These are the essence of number crunching, the essence of being comfortable enough going into algebra to where those abstract concepts aren't lost. Algebra is necessary, even though many students don't like it because it is such an abstract subject and you don't see it in the real world. I promise you, it's being used every day, all the time. It's ingrained in our life. By the time we experience something in the real world, the algebra has already been done. By the time my laptop was finished for me, the algebra that went into creating it was already done. By the time my goods were delivered to me, the algebra of the logistics had already been done for me. Do not think that algebra isn't important. It's absolutely important. And these 7 skills are essential to making sure your student is successful in algebra. Thanks for listening.